All right, section 2.2, we're going to write and solve equations, which we already did some in the last section, 2.15. So now we're just going to step it up to equations that involve the distributive property right there, and have variables on both sides. Okay. So first, basically what this is doing is this is kind of mixing what we did in section 2.1, simplifying things with the distributive property, and then solving equations like we just did in sections 2.15. Okay, so I feel the best way is to just jump in and do some examples. So here we want to solve example 2. We're skipping example 1. It involves Excel. We're not doing it. Here in example 2, here we want to solve this equation. And again, just like that last section, we look at where's my variable? My variable is in there. It's in that parenthesis. So I need to get that variable out by itself. So to do that, I'm going to go ahead and I'm going to, this 5 is multiplied out front here. This 5 is multiplied out front here. So I'm going to take this 5 and I'm going to distribute it in. Okay. So I'm going to take the 5 times the 2x, which is 10x. And then the 5 times, this is technically a negative 3 because of that negative sign. So I'm going to write it as plus a negative 15 plus 4 equals negative 6. So now I always want to look, is this mathematically equivalent to my next step? Okay. Again, notice I've lined up my equal signs all nice. Yep, they are mathematically equivalent. So now I want to simplify. Again, we want to get that x term by itself. So here I can actually take, these are like terms. These are both just constants. So I'm going to put together like terms. The first step in many of these is simplify it down a bit. Okay, so negative 15 plus 4, negative 11 equals negative 6. Okay, so now we're going to go ahead and do what we did with the last section. Okay, and we are going to undo. Okay, again in the backwards order, I have to undo this add a negative 11 first. So I'm going to go ahead and I'm going to add a positive 11 to both sides. So I'm adding that positive 11 to both sides. So now on this side, these two give me 0. So I'm just left with 10x plus 0, which is just 10x, equals negative 6 plus 11 is 5. We divide both sides by 10. And I'm left with 5 divided by 10, which 10 does not go evenly into 5. It's too big. But it is a fraction. I can simplify. They're both divisible by 5. And I get 1/2. Okay, so there's my solution, 1/2. Okay, so now we want to check it. I'm going to put it back up here into this original equation and make sure it works. So I'm going to take 5 times 2 times that 1/2 minus 3, add 4 equals negative 6. So I can check this longhand by hand. It actually doesn't end up being that bad. 2 times 1/2 is 1, minus 3 plus 4. 1 minus 3 is negative 2, so 5 times negative 2 plus 4. 5 times negative 2 is negative 10 plus 4, and that does equal negative 6. Check, it worked, so I know that solution of 1/2. Again, remember, if you notice here, I didn't write a decimal. I wrote a fraction. We want fractions in simplest form unless a decimal makes sense. A problem in which a decimal would make sense would be money. A decimal money would make more sense than a fraction. Half a dollar, 50 cents would make more sense. Okay, or if there's decimals in the original problem. But if there are no decimals in that original problem, stick to fractions. Okay. Next, here we're going to solve this equation. Negative 2x plus 1/2, 6x minus 5 equals 3/2. This one is different from the last, and this first one only had 1x in it, right there. This one's got 2. So the first thing I need to do is simplify this and put together my like terms. So I have 1x here, 1x here. So to put those x's together, I'm going to distribute that 1/2 in. So this negative 2x out front, nothing's happening with him. He just kind of comes along for the ride. Plus, I need to take 1/2 times 6. If you don't know what 1/2 times 6 is, this is where my calculator comes in. 1/2 times 6. Half of 6 is 3. So yes, it is in fact 3. So 3, but they're x's. And then I have 1/2 times -5. I'm going to write that as plus a negative. 1/2 times -5 is -5/2 equals 3/2. Okay, so in that first step, all I did was a distributive property. So I'm going to say I distributed. Okay, so, and sometimes it's useful. So if I'm asked to justify each step, there, I just justified that first step. How did I get from here to here? I distributed. Okay, next, I can go ahead and put these like terms together. Negative 2x plus 3x is 1x. Okay, the reason for that is what? I put together, or I added like terms. I added my like terms. Okay, all right, so now I want to get my x by itself. Got to get this x over here all by himself. So I have my plus my -5, so I'm going to go ahead and undo that, add a -5. Oop. Oh, it keeps going to erase. By adding a +5, 5/2. Okay. So don't let these fractions make you nervous. What was helpful in the past, if I don't know what to do, I cover up those fractions and ask myself, if it was just x plus -5 equals 3, what would I do? Well, I would add a +5 to each side. So, but it's not 5, it's 5/2. So I'm going to add a +5/2 to each side. Okay, so now I need to add 5/2 to this side as well. So now a -5/2 plus +5/2 is 0. Okay, I have 3/2 plus 5/2. Really don't need a calculator for this. They're both halves. So that would give me 8/2, which 8/2 is 4. Now we want to come in, we want to check our work. Oh, I don't know what happened. All right, we're going to check our work. Sorry if you saw that, I don't know. So I need to put a 4 in for both of these x's, for this x and this x. Okay, so I would have a -2 times 4 plus 1/2, 6 times 4 minus 5. And I want to check to see, does that in fact equal 3/2? So order of operations, I need to do like inside parentheses first. So 6 times 4, so I have -2 times 4. 6 times 4 is 24 minus 5. 24 minus 5 is 19. Okay. So then here, -2 times 4 is -8. Plus 19/2. Does that in fact equal 3/2? I don't know. Let's check it. -8 plus parentheses 19/2. Oh, 1.5. Is that the same as 3/2? If you hit the math button, which is right below, you have the blue second button. There's the blue second button. I just turned red, alpha, and then the math button. The second option there is arrow frac. That converts to fraction. So this is taking my previous answer, converting to a fraction, hit enter, 3/2. Yep, so it is 3/2. Check, it worked. All right. Okay, here example 4. Here we want to solve this equation. Okay, so we have 4 times x plus 1 equals -3 times x plus 3. Okay, this is similar to the last one. There's 2 x's. But if you notice, there's one on either side of the equal sign. So to be able to solve something like that, I need to, first we'll simplify it out a bit, and then I need to get all of my x's to the same side. So I have to get my x's, get x to the same side. Okay. So to do that, I need to do some simplifying here first. So I need to do a little distributive property. So I have 4 times x and 4 times 1. So I'd have 4x plus 4 plus this lonely 1 on the end. And then I can distribute on this other side. -3x plus a -9. On the left side, okay, so again, now if I was to be justifying each step, the first step I did was distribute. I didn't finish justifying steps on the last one, so I'm going to do it all for this one. Now we're going to put together like terms. I can add this 4 plus 1. 4x plus 5 equals negative 3x plus negative 9. Justifying for that steps is adding like terms. Okay. Next is this last little bit. I need to get the x to the same side. So to do that, I'm going to move my negative 3x here. Right now it's added to negative 9, so I'm going to add. I'm going to basically use that inverse operation, and it's a negative 3x, so I'm going to add a positive 3x to both sides. Plus 3x. Negative 3x plus negative 9 plus 3x. So now if you notice on this left side, this minus 3x and this positive 3x, since they're adding, they're going to add to 0. My justification for this step is one of the properties, the addition property of equality. Let's go ahead and let's call it that. It's actually the add property of equality. The addition property of equality. Because what I did is I added the same thing to both sides. And now we're going to put together like terms. I can put the 4x and 3x together and get 7x. And then my negative 3x, positive 3x is 0. It's going to equal just negative 9 on that side. Now I'm adding a 5, so I'm going to go ahead and I'm going to add a negative 5 to both sides. Again, my reason, that's still the addition property of equality. I'm adding the same thing to both sides. And then we're going to come back and we're going to add our like terms. My negative 5 plus negative 5 is 0, so 7x. Negative 9 plus negative 5, negative 14. Again, the reason for that, what did I do? I added like terms. I just put my like terms together. Okay, so now I have my 7 times x. To undo a multiply, I divide. I'm going to divide both sides by 7. My reason for that is the division property of equality. Oh, I don't know what happened there. Okay, and negative 14 divided by 7 is negative 2. Now again, we always want to check our work. This one involves a little bit more to check it because I have to put that negative 2 in both sides. 4 times negative 2 plus 1 plus 1. Does that equal negative 3 times negative 2 plus 3? Let's check it. On the left side, negative 2 plus 1 is negative 1. 4 times negative 1 plus 1 is negative 4 plus 1, negative 3. On this left side, negative 3 times negative 2 plus 3 is 1. Negative 3 times 1 is negative 3. Yep, it worked. Both sides ended up being equal to each other. Okay. All right, now we're going to put in a little bit of the second part of 2.1 where we have to actually write the equation. So, word of caution here. This is just a little reminder. When solving a problem involving measurement, whether it's time, whether it's distance, whether it's area, anything that involves if it has a unit. If it has a unit of measure, what do I mean by unit of measure? I don't know, hours, inches, square feet. If it has a unit of measure, I need to check for consistent units. I need to check and make sure that my units are the same throughout the entire problem because I can't be working in an equation and have both seconds and hours in the equation. If I'm dealing with hours, I have to stick with hours. If I'm with seconds, I have to stick with seconds. So it might involve some unit conversion. Okay. So now we're going to go ahead and we're going to solve a problem. Again, I'm going to work through it using that kind of verbal model, and hopefully we'll get used to doing that. So we have two friends here, John and Josh. They live at opposite ends of a trail. They bike toward each other at the speeds shown. So let's go ahead. Let's look at here. We have John on this bike over here. It says he's traveling at 15 miles per hour. And again, he's going this way towards Josh. Here, Josh is traveling at 12 miles an hour. He goes slower, but Josh starts biking 20 minutes before John does. So at the point in which they meet here, they're going to meet at some point here in the middle. Okay. They're going to meet at some point here in the middle. And Josh will have biked for a longer amount of time, but he might not have biked farther because he's going slower. Okay, so I'm just working through and thinking through this problem to see what's going on. So we want to know what distance along the trail measured from John's starting point. So we're looking for this distance from John's starting point. That's really what we're trying to find out. Do the two friends meet? So we're looking for that distance. Okay, so this has a lot of stuff going on. So I'm just going to break it down into the most basic. The distance John travels. John's distance, okay, plus Josh's distance, I know has to be 22 miles. Because the total distance here, this total distance between their houses is 22 miles. So their combined distance can't be more than 22 because they're meeting here in the middle. So I know John's distance plus Josh's distance has to be 22. Okay, so now let's go ahead and let's see if we can come up with something for John's distance. I don't know how far John traveled, but I do know how fast he traveled. This is a speed or a rate. Okay. And it is in miles per hour. It's miles divided by hours. Miles is a distance. Hour is a time. So if I take distance divided by time, I get his rate. Okay, so his distance divided by his time is equal to his rate. So again, I'm trying to find his distance. So if I take both sides of this, here I have this equation here. If I take both sides, I'm going to shorten it D and T, times time, and I'll use R. I get this equation, distance equals rate times time. I'm assuming you probably use this equation at some point in a science class somewhere, but I know John's distance is going to be his rate times his time. Okay. Do I know either of those? I know his rate. His rate is 15 miles per hour. So 15, I'm going to leave the units in for now. 15 miles per hour times his time will give me John's distance. Now we need to do Josh's distance. Again, Josh's distance is also going to be this rate times time idea. Okay. Again, distance equals rate times time. And we know Josh's rate. So again, we're going to do rate times time. But careful, which time? Are they traveling for the same amount of time? Josh is traveling longer. He started 20 minutes before John did. So his time is more. His time is 20 minutes more. Oh, wait. When solving a problem involving measurement, you need to check for consistent units. My units aren't consistent. My rates here are given in miles per hour. Miles per hour, this is 20 minutes. So converting miles per hour is going to be a lot more work than just converting those minutes. So I need to come over here and convert 20 minutes to hours. Okay. So converting 20 minutes, minutes goes here in the denominator, hours up here. 1 hour is equal to 60 minutes. Okay, so 20 divided by 20, that would end up being 20 divided by 60, which is, if we don't know, 0.3 repeating, which as a fraction is 1/3 of an hour. Okay, so this is equal to 1/3 of an hour. Okay, so Josh